This one's on, and that's great. And thank you, Lisa. I'm also the charter member of the Lisa Marie fan club, so I encourage everyone to join. And thank you for inviting us to be part of this panel, and thank you everyone for being here as part of Cloud Native Storage Day. This is a little bit of a different panel than probably what you've seen for most of the day. I've seen some of them. It's always, the whole day has been about storage, obviously. This is the intersection of how storage intersects with security at a platform level. And rather than specific security solutions, what we're going to talk about is some of the things at a higher level. As Lisa mentioned, my name is Michael Kerner. You can follow me on the Twitters at TechJournalist. That's me, which is great. And now we'll just do a quick round of introductions. We'll start with Sheng. If each of you could just introduce yourself. And
yeah, hi, I'm Sheng Liang. I'm a co-founder and CEO of Rancher Labs. We make Kubernetes management software, as many of you know.
Hi, is everyone hearing me okay? Excellent. My name is Bertucio. I'm on the Trust and Security product team at Google Cloud, where I focus on container security.
And I'm Knox Anderson. I work on Sysdig's open source and commercial security products.
So it's a mix, platform, larger platform, vendor. So a whole mix of different things here. And I'm going to leave 10 minutes at the end, and Lisa will tell me when 10 minutes at the end is for questions. So if you have questions for any of us, we'll make sure we save that for the end. And I'll just start with you, Sheng, and just to start. What's your general view on Kubernetes security at this point in time, just at a high macro level? Is it good? Is it bad?
Yeah, I mean, I think security is really what a lot of our users are looking for. I think very early days of Kubernetes, they were a lot more, and even specifically for storage, used to have a lot more emphasis on reliability. I mean, enterprise storage was sort of all about replication, and then it was performance. But security is becoming really important because, as a whole, I think many of the organizations that use Kubernetes that we talk to, in some sense, places security at an even higher level of priority than reliability. And the reason is obvious. Just think about the relative impact of an outage, say, versus a security leak, and it's really not even in the same order of magnitude. So just to answer Sean's question, I think we're at a state in Kubernetes, and the fact that even in a storage specific agenda, there's so much time now dedicated to discuss security. I think it shows, security is really what all the users and customers and vendors care about.
Absolutely. And what are you seeing, Ann?
Yeah, so the interesting thing about Kubernetes, if you compare even just the attendance this week, what it will be to a couple years ago, to then many years ago. I remember going to some of the first KubeCons where it was just a couple hundred people in a small hotel room. Kubernetes is very much matured, and it's being deployed into production at wide scale. The thing I think where we need to be looking to next is making sure people have full understanding of what the security defaults in Kubernetes are. Particularly if you're in a regulated industry, if you're finance, healthcare, everybody has a different security profile, and you need to make sure that you understand what are the defaults, and are those okay for me? Do I need something different? Do I need to look into other hardening mechanisms? And that comes with the maturity of any open source project, but I think that's where Kubernetes security is today.
Makes good sense. And just to interject for a second, one of the defaults in a plain vanilla Kubernetes install until not all that long ago was a default administrative password. So there was a story I wrote and other people wrote as well, that there were a certain number, I think the number was in the 30,000 plus, Kubernetes dashboards that were found unsecured with a basic showdown search. So, you can have all the disaster recovery you want on the storage, you can have your data storage encrypted, but if somebody can access your master dashboard, what's left? What's your general perspective, Knox?
So I'd say we're getting there. If you look at container security a year ago, you'd talk to someone and they'd be like, yeah, I scanned my images, I'm good to go. But now with Kube 1.12 introducing Kubernetes audit policies, you're starting to have people say, hey, I want to get notified if someone updates a config map that has private credentials, or how do I start to actually use PSPs? What are the different ways that I can do file integrity monitoring in my environment? So from an ecosystem perspective, you're actually starting to get some of the right questions, where before it was really just focused on pre-deployment security and some of the scanning best practices.
Very good. And file integrity monitoring is a core capability that's required for PCI DSS. So anyone that's storing data and then needs to be PCI DSS compliant, that's in the United States or even in Europe, I guess, when it's coming across from the various credit card processors, you do need to have file integrity monitoring at some level, 3, 2, I guess. And then Knox, from your perspective, I know you've written a lot of things on container security over time, and I have to pull this one out. I'm a big fan of definitions. About 2 years ago, you wrote the definitive guide to container security terminology, and I know it was definitive in 2017. What do you think has changed over that period, and what's the most misunderstood thing from your perspective at this point in time?
Yeah, so first off, that's probably maybe covering like 25% of what you can do today. I think the thing that's really understood, and one of the first questions, if you talk to a security team that's getting involved with Kubernetes, they're like, hey, how do I do patching in this environment? Like, I need someone to go in, update this container that's running, update a package, things like that. And you're just like, wait, that's not how this works. You need to rebuild this image, send it through your deployment pipeline. If someone deploys a container, no one should ever go in and touch that. So there's a lot of education that you have to do when dealing with security teams on your container platforms. And so one of the things that I've seen works really well for customers, if you have someone from your security team be brought into the architecture committee. So when you're deciding to move forward with Kubernetes, make sure someone from security is involved in the beginning, because 9 times out of 10, we're dealing with teams that got pulled in late, and it's just a mess.
Yeah, I couldn't agree more. And I know, Ann, you spoke earlier today at one of the other co-located conferences, because for those of you that have been in this room the whole day, there are apparently more than one other co-located conference in the general Barcelona area on cloud stuff today. And I know you were talking about a really important concept of shared responsibility. If you just share, no pun intended, if you could share some of that knowledge with us.
Yes, I would be happy to share more about the shared responsibility models. So if you're not familiar, actually, maybe show of hands, how many people does shared responsibility model mean something? Ooh, I see like one hand. Okay, so this is pretty critical then. So your shared responsibility model, it is a model, and your cloud provider has one. Everyone's is slightly different. It's about delineating what the cloud provider is responsible for and what you as the user are responsible for. So if we look at like infrastructure as a service, any of those services, your cloud provider is probably just responsible for kind of that base infrastructure, for protecting it. And we're talking from a security standpoint. But you, the user, made a bunch of choices about what you put on top of that. And you are responsible for protecting, whatever services you're running on top of that. If you look at a SaaS service, on the other hand, you, the user, are responsible for the content and access to that content. And then your provider is responsible for securing the infrastructure that runs that service. Kubernetes is really challenging because it falls somewhere in between there. And there's a lot of different components that, depending on the context of the incident, so we're talking about different security vulnerabilities or issues, and also your cloud provider's policies, those answers may vary. And so it becomes, vulnerability X is disclosed. Is that my job? Is it the provider's job? And so there's a lot of questions that we were going over today about, if I look at Kubernetes, what are some of the big components, be it the Node OS upgrades, the control plane, that you need to make sure that you understand that you are responsible for securing. So that's what we were talking about this morning.
Yeah, it's an important question, because some people think, we can talk about this as a group also, everything should be secure by default, but that's not necessarily true. And I know, Sheng, at Rancher you have a platform, an open source platform, et cetera. What sort of security controls do you have that you could talk about that are important when we think about having both that shared responsibility and then some degree of intelligent defaults?
Yeah, I mean, this is a very big deal, because just follow up Ann's point about shared responsibility. One thing we're seeing with Kubernetes is there are many ways of using Kubernetes. So just give you kind of two predominant way. One way is you would use something like GKE or EKS, where in those cases certainly the cloud provider will really be responsible for the operational practices and fundamental configuration and the security angle of operating the cluster itself. Whereas there's still a lot of people, a lot of DevOps team out there who are more than comfortable of standing up and operate Kubernetes on their own. And they, on the other side will be an infrastructure team who's providing them with VMs or bare metal servers. So those are very, very different scope of responsibilities. And one thing we've had to do in our product is to make sure that the cluster configurations and security policies are done correctly across the board. And Kubernetes is a very powerful and very flexible platform. But in some cases, what we observed is our users are really having trouble, making sure that they can define a meaningful set of policies and have that enforced across the board, regardless where they're getting Kubernetes from. And it is very important. Most organizations today have, especially larger organizations, do have to deal with multiple infrastructure that they use to use, maybe even multiple type of on-premise infrastructure or multiple clouds that they use to run Kubernetes. And so this is the nice thing about Kubernetes is everything is configurable, and a lot of these things are API driven or config file driven, but someone so you kind of have to have a framework to make sense of all of that and define the policies and enforce these policies for the right set of for the user, depending on what role the user assumes. So it's actually kind of given us an opportunity to build a product around that. So it is actually I think. Security in this case, the way I look at it, is actually a great business opportunity for us because it's a problem that all of the Kubernetes users really have to solve.
And then I'll just go right to left or left to right from my side. From your perspective, Sheng, given that customers, organizations, anybody needs to figure out what these right policies are, what sort of interesting war stories, as it were, customer stories without naming people, have you seen where people did things really wrong and they had to help them, or they did something really right and it helped them be better and avoid ending up,
Yeah, I mean, I think, I kind of maybe just use a slightly different story, which is something we experienced as a community. I think I attended the Container Security Summit, and I think you helped organize, right, at Google, and there was a talk about the wars, the battle of the experiences of finding one of the early or very first Kubernetes CVEs, and we happen to be involved in that because, and I know many of you in this room work on storage, but and that's really interesting because in the process of finding that CVE, we uncovered that CVE. For about a year, we believed that there was a bug in AWS ELB that's kind of causing Kubernetes to misbehave, causing our Kubernetes to misbehave, and we really don't have any other means of explaining the behavior because it happens with ELB, but once we switch to ALB, it doesn't, it's not reproducible anymore, and it's an interesting behavior, and it turned out to be, as we actually take it a little bit more seriously, it turned out to be an interesting corner case that the API server in Kubernetes really wasn't handling right. And then as we really thought about it, it could actually, because I thought for a while we thought, okay, that might be the case, but that's kind of a minor inconvenience. You can kind of actually work around with some behavior, with some special configuration in load balancer, and But it turned out actually no, because it turned out if you don't actually work that around in load balancer, if you actually just exposed the API server directly to the internet, it could be a pretty serious, potentially pretty serious, privilege escalation issue. So we kind of just reported that as a security issue to the security team. The Kubernetes security team. Then it was fixed just within a matter of days, and it was patched for everyone. So I think that what I learned from, I know this is not really a situation of misconfiguring Kubernetes clusters, but this is actually a little bit more fundamental. But what I really learned from that is a lot of times, I mean, these security issues kind of manifest themselves as as networking issues, load balancing issues, scheduling issues, or storage issues. So many of the things really we work on every day when we kind of see a surprising behavior. I mean, sometimes there are just unexpected ways that the system could be exploited, and we just got to be all very vigilant to go after those use cases, because if we don't, then sometimes a hacker might find it and cause a lot of harm to the whole community.
Exactly, and thanks to Shodan, there's nowhere you can hide. If you're publicly on the internet, then you're publicly accessible to hackers. What's sort of interesting, I know you've got a story to share, Anne, so.
I do, yeah. I have a positive example. So I'll tell you a story about a Kubernetes user, and I think they're doing a really wonderful job of thinking ahead about how has their infrastructure changed, and how has that changed their threat profile, how has that changed their security profile, and planning for that. So this is a sizable research institution, and there's a massive heap of researchers, as well as these research institutions do a lot of collaboration with other consortiums. They're pulling in a lot of data. And there's a rather small infrastructure team with an even smaller security team that is responsible for making sure all of these researchers have the compute resources that they need. And so they're running Kubernetes, and as they've kind of evolved in their Kubernetes journey, they've realized that they have to switch. And even though all these researchers, they're employees, they are on the inside of, if we think of the old firewall models, they're inside the firewall. The security team and the infrastructure team decided, you know what, we are going to address every researcher as mutually untrusting. And so all these researchers have their ML data sets, they have their ML models, they'd like to run it on the compute, and they said, you know what, we're going to now look at how, we realize our threat model has changed, security boundaries have changed, we're going to start looking into container isolation. And so they are, as they continue to build things out, they're already thinking ahead about what do I need to do. They're looking at things like gvisor, they're looking at things like Kata containers to make sure they have a plan. And I just think that's that's an example of a really aware team who has decided we need to change how we're thinking about this, and then we're going to change our infrastructure accordingly. So there's my positive war story.
That's a good story, because my line of work, writing that Kubernetes worked just fine. There were no security incidents today, and storage was accessible at speed of thought. That's not a story. It's only when things break that I get to write. So happy to share these kinds of stories here, but I'm also happy to hear the bad ones too. Do you have an interesting story that you could share with us, Knox, whether it's an engagement or one you're aware of anecdotally or otherwise?
Yeah, so show of hands, who in the room has used Wireshark before? Okay, decent amount. So our founders he was heavily involved in the Wireshark project, and one of the changes that happens in containers is you don't have a span port to kick into. Basically what we've done is released a kube control plugin where you can trigger these things called Sysdig captures. It's fully open source, and what it allows you to do is take a dump of all the system calls that happened at that point in time when an event occurred. So probably once a week we get a Slack message from someone on the open source channel that says, hey, I've got this SCAP file, something's going on, can you help me? So if anyone in the room has Google open, just Google Sysdig versus malware. And we had a customer, I think 2 or 3 weeks ago, that came and said, I have this host that has really bad IP reputation, I don't know why. And so someone had basically forked the MumbleHard vulnerability, which was really big back in 2015.
Yeah.
Changed some of the IPs that was interacting with. And so you can go through this capture file and trace the process, see all the different network communications that process is making, the payload, and all that kind of stuff. So
we're really taking system calls as the new source of truth. People used to always say packets never lie, but you don't really have access to that in these container environments.
That's absolutely true. And you're always, well, the source of truth is always a difficult thing. In the old world, it would have just been, you say, a SIM, the Security Information Event Manager in the SOC, and that's it. And it might still be true at a higher level, but as you say, system calls. And I know the overall schedule was a little bit late, so I wanted to make sure there's enough time for questions. Okay, if anyone has questions, I've got a couple minutes, or we can take 5 minutes questions. Otherwise, I've got a couple last ones for the audience. So if anyone has any questions.
Thank you.
Any questions? We got one.
Yeah, so this is one of the things that we're addressing with our product. So we have an agent that sits on your infrastructure, and then we're comparing that with all the data that we pulled from your containers pre-deployment with an open source tool called Anchor. So Anchor is great in that they index all the packages that are part of a container image, and then they're constantly checking that package list against all the different CVE feeds. So in comparison to other scanners where you're scanning a registry once every 24 hours to uncover CVEs, since they have that package history, you'll get updated in real time. And so we're taking that data and marrying it with our agent that's then pulling all the different Kubernetes labels. So if you want to run a query that says, show me all images that are running in this namespace that have a critical vulnerability with a fix that's more than 30 days old, those are the types of things that you can do with our offering.
Yeah, I mean, if I just add something real quick to that, I mean, these days I see a lot of Rancher users are actually very proactive about these things. They don't necessarily even wait for the scan to tell them, like they would, because containers are immutable. So what they do is like they would say every month, I'll just refresh the containers, and even the host operating system. So Kubernetes let you do all of that really without impacting the reliability of the workload itself. So that's very cool. You can basically restart all the containers and restart all the nodes, evacuate pods if necessary, and make sure your container image is never then say more than a month or a week old. And that definitely proactively get around a lot of those problems.
We've got a question over there.
And then one last thing to add, I'd also always front your Kubernetes clusters with admission controllers with validating webhooks so that you can say, if this image had failed a policy, prevent it from even being deployed.
So my question is on the
Of course, it's the one who doesn't have.
Actually, there are a lot of experts in the audience. I see folks from Portworx or Storage OS, OpenEBS. I'm sure they all have a lot to say about this. But I mean, it's really exciting for me to be here to talk about security, even though I'm not really a security expert like these two people. Because when if you compare storage with networking, when Rancher Labs we started our initial project, we had to do this cross host networking. And very, very simply, people just choose, the engineer who did it just to choose to use IPsec, because for networking guys, it's very natural. Of course, cross-host networking should be by default encrypted. And we've been working on, I mean, a lot of storage people know this, we've been working on this storage project called Longhorn, and it's an open source sort of distributed block storage project. And even today, I could tell you Longhorn does not support encrypted storage. So it just seems like users or customers don't demand the level of encryption on storage as much as they demand on networking. And traditionally, the answer to that is they say if you have something really sensitive, then you should store it as a secret or something, or keep it, or maybe encrypt it in your application. But I think as a whole, we would be a lot better served if we start demanding, storage systems to by default encrypt everything, just like HTTPS encrypts everything, right, on the wire. At least storage, we could start with encrypt everything at rest, because that's where most of the attack vectors are. And of course, that brings out a whole bunch of technical problems. Like now, how do you manage the keys, so which would also have to be stored somewhere. But I think it's better to solve these problems up front. There are actually a lot of interesting discussions going on in the community. That's a great question. I think this has always been a point I'm very passionate about, and I hope like folks at StorageOS or Portworx or OpenEBS or NetApp, they would all start talking about this.
And I'll just add in on that policy matters, because you can have an encrypted volume or otherwise, but if everybody has access to the encrypted volume, who cares that it's encrypted? So proper role-based access control, or use open policy agent or something, so that you only have the right people getting the right access. And then equally important, having some kind of user and entity behavior analytics afterwards, because any user can be compromised at any time. So if you have established that there's a baseline that this is what this person does, great. And then if there's a deviation or otherwise thing that looks like an outlier, you can identify that, because I see encryption as being table stakes, as it were. It's important. But you have to define the access to that. We're probably just about out of time, so we could take one more question, or actually I'll ask the last question to
Okay,
up
I
here.
promise we will get you out of here on time. Nobody leave. We're going to steal some time from one of the other talks, but you'll have lots of multi-cloud, and you'll have one more chance to hear about security.
We'll just have one last question here, and this is just the takeaways, because when you go back to your management and your offices, people will always say, well, what did you learn at Cloud Native Storage Day? And I'm sure you learned lots about disaster recovery and how to configure storage volumes and the like, and I want to make sure you have something from this panel as well. So I'll just start with Sheng, and just what do you think is a key takeaway that people in this audience should take back to their management and their firms back home, what they should know about container security as it relates to this topic?
No, I would say storage, storage shouldn't just reliably store data and backup data. We should absolutely make sure sensitive data never gets leaked through storage. So security is paramount for storage.
And I would say from the vulnerability management and open source security perspective, so I have two takeaways for you. One is for all your services, know what you're responsible for, and that's that shared responsibility model. For all your services, you can go to your provider and say, hey, what do you protect? What do I protect? Have a really good understanding of that. My second thing that kind of gets to your question, I think on the show floor, you're probably going to see a lot of open source cloud native storage projects, different things. For anything that you decide to bring into your environment, any of these open source projects, it's really important that you understand where in that community you receive security announcements. There was a recent open source security survey, and about 30% of respondents said that if there was a vulnerability in one of the open source projects they consume, they would not know how to find out about it. And that's a good chunk of people who are potentially vulnerable for things that have easy patches. So I'd encourage you, as you're walking the show floor, checking out the new open source projects, if you decide to adopt them, make sure you understand where you get latest updates about vulnerabilities and security announcements.
And then I'd say to learn how to use the Kubernetes defaults. So things like pod security policies, network policies, admission controllers. So PSPs, for example, you can define what are the volumes this pod should have access to, what are the allowed host paths, and a bunch of other different parameters there. So PSPs, on the other hand, like if you go to the Kubernetes security Slack channel, probably 50% of the questions are like, how do I deploy this? How do I use this? There's a good open source project called PSP Advisor that goes in and scrapes all of your configuration and then auto-generates PSPs based on that. And so it allows you to kind of have an iterative process on creating those PSPs. But really, Kubernetes should be what's doing the prevention in your environment that shouldn't be handled by a tool. And that's something where the sooner you can adopt those native Kubernetes features, the better.
Fantastic. Well, thanks, Knox, Ann, and Shannon for being on this panel. Thank you to Lisa and the Cloud Native Storage Day for having us. And thank you all for being here, and we'll thank our panelists. Thank you.